Nowadays, with the rise of new opportunities to create beneficial applications in virtual environments, the design of effective methods for translating and rotating virtual objects become a significant research target. Mirror interactions prove to be a viable solution to provide intuitive manipulation, yet hand tracking techniques are not widely explored in virtual reality. Other mirror interaction techniques using controllers as input devices also show promising results. However, prolonged periods of use can cause fatigue while performing basic manipulation tasks. Therefore, how can we design effective and precise gesture-based manipulation techniques in virtual reality to translate and rotate 3D objects that at the same time produce low fatigue? In this project, we present Gestector, a set of manipulation techniques that allows the user to rotate and translate virtual objects through intuitively hand gestures. After grabbing a virtual object, the user can activate the rotation technique by applying the palm up gesture followed by the extender finger gesture, causing the object to levitate a few centimeters above the user's hand. This allows a complete rotation using the other free hand. This method removes the limitation of one-hand rotation. For translation, the user can use one-handed ray projection method to select a distant object. Applying the palm up gesture with the other free hand will make the object levitate. Then the user can bring the object with the closed fingers gesture. The object can return to the desired position with the palm down gesture. This method allows out-of-reach object translation. Gestector uses a lift motion controller for capture hand movements, attached to an Oculus Rift S headset. The techniques were developed extending and modifying the lift motion API, making it possible to create gesture detection. We conducted an evaluation study with 2 participants for testing the manipulation techniques. Participants were first asked to complete a simple task so that they could understand how to use Gestector. Then, they were asked to complete a specific task scenario for each technique. We interviewed both participants separately before and after the test. Our findings show that using hand gestures to manipulate virtual objects proved to be intuitive for the participants in our study. They demonstrated fast accommodation to the techniques and improved their task performance over time. The fatigue generated by the techniques was not very significant. Participants felt comfortable performing in all the proposed tasks. Evaluation results show that rotation accuracy needs to be improved. However, restricting full rotation with an alternative method can yield positive results. Overall, the insights from our studies contribute to designers of virtual environments to use alternative methods when it comes to creating novel interactions using hand gestures.